Okay, guys, I'm just going to help you out with these single displacement reactions. Um, so the things you need always, this is what is great about these resource sheets. You always want to come to solving these problems or working with these worksheets with your, uh, now you're up to 3 sheets. So you have your colored periodic table, you have your polyatomic ions. I call it the polyatomic ion worksheet, but it also has the Latin prefixes for your naming. It has some diatomic stuff as well. Things that can help you. So it's so many times I talk about this being like a puzzle, and it truly is when you have these sheets, they can really help you. And then of course this new one we're working on is the activity series. Now in the content part, I asked you to add some language to it. It was about the metals from lithium to sodium or replace hydrogen from an acid and water. Now, you actually could solve that by looking at this activity series, but I just like to add information to this. Another thing that I also added was most reactive, and I also added here because easily loses electrons, and that becomes really important in understanding why these reactions take place. So this H from acid and water, I've just put a, whoops, that shouldn't be there. I've just put a little line there, and it really is just a picture of what that first statement is saying. Now you don't need to include that, but I did. And then it goes down to lead, from sodium to lead was the second part. So I just like to again have that on the worksheet. So let's look here at the some of the equations. So here's the worksheet. I'm going to back this out a little bit. Okay, so good enough there. This is the worksheet that you're going to be completing. So we're now, and we're not showing you the complete equation. We've worked with balancing and other things, naming. But now we're saying here's some reactions. They're all single displacement reactions potentially. And the question now is, as you get more and more knowledgeable as a chemist, will this reaction happen? So I'm going to take a couple of the reactions and I'm going to walk through with you how to do them, and then you're going to work on the worksheet and complete it. Okay, so let's look at let's go to 4. Okay, 4. So number 4 says, I should move that over more, is chlorine gas plus potassium iodine, and then we're saying, will this reaction happen? Okay. So this is actually one that deals with the non-metal. So that's the first thing. Okay, what am I dealing with? I'm dealing with a non-metal. I'm dealing with a non-metal, and I'm dealing with a metal. Okay, you can see the metal is the odd one out here. So it is going to have to be with the reaction between the metal and the non-metal, but which non-metal it is, we're not sure yet. So the best way to visualize these is to draw your particle equation, and you see me going to this a lot. Okay, and it's not balanced. We don't know if it's balanced yet until we see if this reaction will take place. Excuse me. So a metal, from your learning so far, we know that metals, blues on our periodic table, are going to lose electrons. We know that nonmetals, and I happen to color them in pink here, are going to gain electrons. So in this situation, the metal is going to lose electrons. We know that's going to be oxidized. You learned about Leo the lion goes grr. So lose electrons, oxidize, and the iodine is going to gain. Okay, and this is just a like a pure covalent bond. So they're just equally sharing. There's not a redox happening in here. So the question is, if I was to take a container and put a whole bunch of chlorine gas in it and a whole bunch of iodine gas in it, and I had a chunk of potassium metal, so this is Miss Webb making it a particle picture, is the iodine going to react with the potassium, or is the chlorine going to react with the potassium? Right now, they're showing that the iodine has reacted with the potassium. And I'm going to go through this fairly quickly because you can pause and pause the video and take some time to maybe go look at some previous notes if anything that I've mentioned so far is you're not familiar with. So what the chemists have done, made these wonderful activity series charts. And we're going to look here at the nonmetals. We're looking at fluorine, chlorine, bromine, and iodine. And very similar to the metals, that we know that at the top, they're going to more easily gain electrons than the iodine. Because remember, and this is actually something, sorry, this is actually something that we could add right now to the sheet. Let's do it. So this is gains electrons easily. Sorry, I just had a cough there. So I'm writing gains electrons easily. And we say that this attracts electrons easily. Remember, these are non-metals, so they're going to gain electrons. And I say attracts electrons easily. And then down here is it still attracts electrons, but it's less active or less of an attraction. So attracts less. So this one is more attracted to the electrons, and this is less attracted to the electrons. So if we go back here, we say, okay, iodine, again, you have to know, you have to be thinking non-metal. Non-metal is going to attract the electron. So iodine as right now attracted potassium's electron, and I'm just going to put a single electron in here. I'm not showing the actual correct bonding. And so this is a bond. Okay. Now the reaction can, you know, the question is it easier for chlorine to attract potassium's electron, or is it quite stable right now with iodine attracting um, potassium's electron? So looking at our series, we can see that chlorine is above iodine. So that means chlorine, what does this mean? Chlorine is more attracted to potassium's electron. So guess what's going to happen? If chlorine's more attracted to potassium's electron, chlorine's going to bump iodine out and replace iodine. So what does that look like? We're going to bump iodine out, and there ends up being two of them by the time the reaction is done. And the potassium is now going to be bonded to the chlorine. And you see how that bumping out has happened. So now chlorine is more attracted to potassium's electron, so it bumps iodine out. Iodine out. So back up here, what would that look like? I2, it's one of those special molecules that of the halogens. All the halogens are found diatomic, two atoms together. There's our two atoms together, plus potassium chloride. Okay. And we need to balance this. It ends up being two potassiums and two potassium chlorides. Okay, so that's an example of, again, you can pause this and write some notes and if you need to, that's how that reaction uh, would work. And it would work. This one would proceed. There would be a reaction that would happen. Okay, let's try one like this. Copper. This is number, which one is this? I think this is number 10. Copper plus aluminum sulfate produces, and we're saying, okay, you're a chemist. We're going to put a big solution of aluminum sulfate. 2, 3, 4. There's two aluminums in it. Right? So there's my picture of aluminum sulfate, two aluminums. I see a polyatomic here, and there would be like trillions and trillions of them. But I'll just make two. And I drop a chunk of copper pipe or something like that. And I look at this, okay, and I got a new potential reaction that's going to happen. So what do I see here? I go back to my periodic table and I go, okay, I'm dealing with a metal and I'm dealing with another metal, but now I'm dealing with a polyatomic ion. And if you're like, oh, miss, I don't remember those. Sorry, I'm writing small here. Polyatomic, that's a polyatomic ion. I could go to my other sheet and I could say, sulfate. There it is right there. SO4 2 negative, sulfate ion. When it's combined with the aluminum sulfate. So the question is, will this reaction proceed? Right now, I'm going to blow up my, make a bigger picture of my sulfate. Okay, so I have my picture of my aluminum sulfate, and the question is, if I got copper exposed to it, is it easier for the sulfate to stay bonded to the aluminum, or is it easier for it to bond to copper? So how do we know that? Now we're looking at the metal part of the series. And I'm going to look for my aluminum and my copper, because the question is, will the sulfate switch partners with aluminum and replace it with copper? So I find copper here, and I find aluminum here. Okay. And I see aluminum is above copper. So that means aluminum, it's easier for aluminum to lose electrons than copper. So right now, sulfate is bonded to aluminum, which is an easier source of electrons. So there would be no reaction. This would not happen. Now, if I was to put this aluminum sulfate into a bunch of calcium, I'm just playing around here to say, if I was to put this in a container that had a bunch of calcium, you can see now that the calcium is above the aluminum, so it's an easier source of electrons, this would bump this out. That reaction would happen. Okay, so there's an example of no reaction. I'm just going to do one more for you to help you with this. Let's do a big polyatomic one again. I'll do one of the biggest questions that's on here to help you out with that. That's number 3. Okay, number 3 is aluminum plus H2SO4, which is an acid. And the question is, will this reaction proceed? Okay, so I'm going to go to my picture, aluminum, and I'm going to draw my sulfate, that polyatomic. That's where it's so important to recognize those sulfates. And I'm going to put a hydrogen here and a hydrogen here. So just like the last question, we've got our sulfate here. And the question is it easier for sulfate to stay bonded to this hydrogen, or is it easy for it to actually be take aluminum's electrons, form the bond with aluminum electrons? So how do we know that? Well, thank goodness, thousands of other experiments have been done, and this beautiful table is designed. And I'm going to look at aluminum, and I'm going to look at hydrogen. So hydrogen is way down here. Okay. So I've got aluminum and hydrogen. I see because aluminum's above hydrogen, it is more easily going to lose its electrons. So sulfate's going to go, well, I don't mean to anthropomorphizing molecules, but let's say sulfate says, hey, why would I stay bonded with hydrogen when there's a much easier source of electrons from aluminum? So because aluminum is above hydrogen in that activity series, it's actually going to bump out hydrogen. And so the next picture, I can use this with the whiteboard. This is what's great about this, is you're actually going to see aluminum is going to bond to the sulfate, and hydrogen gets kicked out. Okay, so aluminum gets oxidized and hydrogen gets reduced. So what does this look like? That's number 3, right? So there's our hydrogen gas. It always forms as H2. And actually, I'm going to stop and talk to you about that. If you're unsure if what the structure is, or the formula or the name of these are, there is the super 7 diatomic molecules that they talk about at the back here. 1, 2, 3, 4, 5, 6, 7. These 7 always come as diatomic, so there's always 2 of them. So when you talk about iodine, it's I2. When you say bromine, it's Br2. Okay? When they're by themselves. So this is hydrogen gas plus Al2, and let me just check without me. I think it's 2. No, it's 3. Okay, so balanced. I'm going to actually go through and quickly draw my particle pictures so that you can see me balance this. Can never balance too much. There's my hydrogen, produces hydrogen gas. And this is really cool how the sulfate bonds with the aluminum. Another sulfate. Okay, and another aluminum. I see there's 2 aluminums. And this is all one quite large molecule. So if I look at this, just to review, I see here 3 sulfates. Okay, 1, 2, 3. Okay. I see 2 aluminums. 1, too. So that's my one molecule of it. And if I go back and forth, I see there's two aluminums here. There must be another aluminum here. I see I've got uh, one sulfate here, but I'm seeing three sulfates there. So get going, Miss Webb. One. Again, there are other methods of um, balancing. I just love the particle picture one. I refer to it all the time. But if you go, Miss Webb, that doesn't work for me. Go Google it. There's great suggestions out there for how to do it. So this is I got my three sulfates. I have my three sulfates are balanced. I have 1, 2, 3, 4, 5, 6 hydrogens. So I got to add a few more hydrogens. And if I look at this, I would say this is balanced now. So it ends up being two, one, two aluminums, 1, 2, 3 of the acids, 1, 2, 3 of the hydrogen gases, and one aluminum sulfate. Okay, so that's helping you, first of all, so you see how we're just getting more and more building up on our foundation. Okay, so now you're becoming predictors of reactions, and then all the other stuff of balancing, what type of reaction, that's from that foundation that you built. Okay, hopefully this helps you out. If not, I'm always available for help. Have fun.